Hello, hello. Thank you everybody for coming. Thanks. So we are Cube Creative, an animation studio based in Paris, and we are very happy to be here for our 5th Blender conference today. So what is Cube Creative? We are, as I said, an animation studio in Paris. We are part of the Xylam animation group. Historically, we've been involved in a vast variety of projects, such as commercials, rides for amusement parks, special effects for feature films, and TV series. And in the past few years, we have been more focused on 3D TV series. Some are for kids and other for every ages. So first of all, a bit about ourselves. I'm here with this handsome young man. He's Swann Martinez, one of our in-house developers. He's involved in the long-term pipeline design and also in the development of most of our tools. Swann will be handling the most technical parts of the talk today. And my name is Tanguy. I'm one of the CG supervisors at Cube, and I'm currently in charge of lighting and rendering on a project called Piggy Builders, which is a TV series for kids. So to give you a more precise idea of the kind of images we work on and the kind of projects we tackle, we're going to show you a short reel of all our projects. Thank you. So for those of you who followed our previous talk, this one will be a bit more on the technical side of things. We're going to talk a bit about development and pipeline decisions. But don't worry, we've included some funny GIFs for keeping you entertained until the end. So today we'll be sharing with you how we use and contribute to open source tools to build a richer and more flexible pipeline, and more specifically, how we adapt those tools to the rest of our existing pipeline. Hopefully, this can be an inspiration for other studios. And to illustrate that, we're going to show you and share with you 2 case studies. So first of all, I'm going to go over a brief overview of our creation workflow, just to give you a bit of context, and also a brief overview of our decision process in terms of pipeline. Then Swann will be talking about a bit more in-depth about our use of the Blender Kitsu add-on, which is developed by the Blender Studio, and how we use it for editing purposes at Cube. Then we move on to our second case study, which is the creation of an animation library from the Pose library that is shipped with Blender, and how we extended it to fit our needs. And lastly, we'll share with you what we learned during this process and what we will aim at in the future from this experience. So, first of all, a bit about pipeline and how we build one at Cube. So what is a pipeline? Here's a definition among others. The pipeline is the glue that holds together the work of all the different artists in a production. So this is one definition, but it tells us something about the strong relation that exists and that binds the tools and the productions it serves. So what's the issue with these tools, with this relation, you may ask? Well, the main thing is that pipeline tools are, for the vast majority of them, created during a production for the said production needs. This means that the production pace dictates the development pace. And this also means that we don't have the time to take a step back, and developers often have to work with a very tight schedule and a lack of visibility on what's coming next. This leads to rushed development and tools that fit the needs of only one specific project. And as a result, we end up with a disposable pipeline that cannot really be used efficiently when moving to a different project that has different needs. And everything or most of the tools have to be done all over again. So let's talk a bit how we try to avoid this pitfall at Cube and the decision process we try to strictly follow when talking about pipeline and tools development. So for the past few years, we did our best to follow those principles in terms of design. It all starts with the production management team, which has all the information about how much money and time we've got on our hands. So they set the goals and deadline in which those goals have to be reached. Then come the technical supervision team, and together we collectively discuss and define the needed tools for said production in order to be able to meet the goals and deadlines set by the production management team. This tools wish list is then brought to our R&D team. So it can be things very specific, like we need a more efficient way of dealing with the animation library, or we need a way to automatically light our shots with such and such features. And of course, we need to be reasonable with this wish list because the developers run on the project funds. So we certainly do not have unlimited development powers for the tool. So we have to choose wisely in what we want to invest this time. And then the R&D deliver those tools defined by the technical team in the priority order defined by the production management team. And keep in mind that in an ideal world, everything happens well before the start of a production, but of course we have to make do with what we have. And for instance, the animation library development that Swann will talk a bit more about later started during the production I'm involved with. So we have to make do with that too. So hopefully, if we follow this principle, we end up with flexible tools that are suited for different kind of production, and we don't have to develop new tools for every production. But now that we've taken a step back and we're happy with our tools, we want to share those tools with other studios, and we end up with the same limits, but just at a different scale. Because the tools were developed in the context of our production, they don't fit the context of other studios. So we end up with a disposable set of tools that other studios has to develop, because every studio reinvent the wheel, and we're not exception to the rule, even though we try to share some bits of our code. So this is specifically what we are going to talk today. How do we make sure that the tool we use and share are suitable for other studios and other infrastructure? And what role open source plays in this quest for reusability? So now a bit about our pipeline. This is a very brief overview of our creation workflow. I won't go into details at all because there's nothing too original here. It's very straightforward. It's just to give you an idea of how the two case studies we're going to talk about are interacting with the rest of the steps of production. So the first use case is our use of Blender Kitsu for editing. One thing to notice here that will be relevant for the rest of the talk is that the proper editing is handled by the post-production department at Tillement Animation. So as an animation studio entity, we only deliver individual shots, and they take care of the proper editing. What we use Blender Kitsu for is more of for updating our episodes along the production to make sure we have the latest versions of layout, animation, lighting, and such, but not for proper editing. As you can see, this first case study is particularly linked to many steps of the production. The second case study is the animation library, and this is related to less parts of the pipeline because it only interacts and it's only used at layout and animation stage. So let's go for our first case study, which is using Blender Kitsu as an editing hub. So I'm going to first show you where do we come from and how was our old editing workflow. You will get in a few slides why the word editing is crossed out. So first we start with the animatic, which is a video version of the 2D storyboard. And this animatic is important and manually cut into an editing software. In this case is DaVinci Resolve. And with that we can make an EDL file that contains all the shot frame range data. Then this animatic video and EDL file are brought into our in-house editing tool, which is called Eve Montage. And with only one click, we can create all the shots into Kitsu with the proper frame range and metadata, and also create all the individual media files for the shots, which are the sound and video, which are then linked into the working blend files for layout and animation, so they know what they have to work with. And second feature of this editing tool is for later in production, when we have all the previews for the different production steps, we can then, this tool can then access them to create an up-to-date editing version of the episode. But keep in mind that it's not properly editing. It's only all the shots, one after the other in a long video, but we don't have crossfades, we don't have split screens, we don't have incrustation of one shot into another in case of a screen shown in a shot. So this is why it's not proper editing. So what are the main issues with this tool? You may have guessed a few already, but the first one is we rely on FFmpeg, and if some of you have worked with FFmpeg, you know that all the interdependent commands can be really complex with, and we ended up with a factory that would work in a very opaque and complex manner, which made it hard to maintain and to debug and to add features. Then the interface, the user interface looks like that. As you see, it's just a glorified spreadsheet. So for an editing tool, it's not at all a what you see is what you got approach, which is a bit of a pain. And we didn't have any proper editing features. So we end up with an editing tool that has no editing UI and no proper editing features, which is a bit silly, right? And on top of that, because of the complexity of the tool, every slight change in feature or trying to maintain it could break everything. And in fact, we actually managed to break everything a few times in the past 6 years, during which we used this tool for editing. So this is what happens when the production pace dictates the development pace. And this is what we want to avoid. And last year, at Beacon 2023, we saw a talk by Nick Arbarelli, and he showed us how he used Blender Kitsu for editing, and it was everything we needed. It was much better than what we had at home. So we immediately thought we have to have a serious look at this, and we want to use it.
On the paper, the tool really met our needs. It has what you see is what you get approach with the video sequence editor. It has an intuitive metadata editing interface. and it was Blender-based as the rest of our pipeline. So let's go. Now comes the hardest part, integrating it in 1 month. That was actually our main constraint. We will approach the pipeline integration in temporal order. Firstly, how we retrieve and distribute Blender Kitsu in the studio. Then we will see how we made the add-on talk with our file system infrastructure. And finally, I will go through the missing features. But before testing anything, the first question was how to get Blender Kitsu in our infrastructure. To give a bit of context, Blender Kitsu source code is located, among others, Blender Studio add-ons and tools and scripts in a big repository called the Blender Studio Pipeline. And as we needed only Blender Kitsu, the question was how to get rid of everything else without losing the code history and the capacity to easily upstream our modification to the Blender Studio main repository. So basically, how to distribute Blender Kitsu within the studio. To handle this, we started to fork the Blender Studio pipeline on project.blender.org. The fork allowed us to keep the source history and eventually upstream useful commits for the community. Then we cloned our own fork in our in-house code hosting platform, which is GitLab, in order to isolate the studio context-related configuration that basically contains sensitive information about our infrastructure. The issue with the fork was that we kept all unnecessary add-ons and script sources. So on the development side, we relied on sparse checkout to reduce the file tree to only Blender Kitsu. So the next question was how to distribute it to the studio, to the artist, basically. Our first step consisted to create an application template called Jamily Cut This that basically handles Blender configuration at launch and opens a pre-configured workspace with the video sequence editor. As the Blender Studio pipeline was already structured as the Python package, we easily managed to publish it to our private PyPy index. We just added a basic manifest file to describe what was kept at build time, thus allowing us to only distribute Blender Kitsu. Once the add-on was published, we used some CI script on Jamily Cut This, which is a basic repository with just the template scripts that allowed us to build a standalone application pushed to a simple network share, available to the artists. Once the add-on was published, we were able to launch Blender Kitsu in one click within our pipeline. Woo! But few issues remain. As we started to benchmark Blender Kitsu within our pipeline and infrastructure, an obvious problem showed up. Blender Kitsu was not able to communicate with our file system. That being said, it was close to work out of the box. The tool was designed to behave within an infrastructure similar to the Blender Studio. The fact is, with very different infrastructure and file organization, it's a bit like we tried to plug in an unadapted socket. So let's take a step back and see how we handle infrastructure-dependent issues in the Cube's pipeline core design. At Cube Creative, we try to define the pipeline as small reusable building blocks, ultimately, those building blocks depend on each other. Now, to create each one of those building blocks, we try to apply domain-driven design, a software design approach which consists to start by defining the domain of the software or any block of code, which is basically a set of entities and use case implementing the core logic of the business. Then the application layer is instancing and calling the domain logic. Now, if our software needs to talk to an external client, such as a database, for instance, we define an abstract interface, also called a port, which specifies the need of our domain concerning this client. Then we implement the client-specific interface as an adapter in the infrastructure layer with client-related code. By doing this way, if an external dependency change, it won't impact the core logic of the software, or with a minimal impact. So this allowed us to reduce core logic dependencies to external clients. So, in terms of domain-driven design, what is the domain of Blender Kitsu, the video sequence editor module more specifically? The obvious one is handling editing synchronization with Kitsu. But there is another one which consists to resolve media path. And the issue with that is that in our infrastructure, that was the domain of Path Part 2. And in our module, that holds the responsibility of the project file structure. Given a file structure definition file, its job is quite simple. It consists to generate path from metadata and vice versa. So how to tackle this situation? Well, to let Blender Kitsu work with our infrastructure without breaking Blender Studio infrastructure compatibility. And port adapter should do the trick. So we started by adding a port called Abstract Path Resolver, on which the domain could rely. Then we added two adapters implementations, one for the Blender Studio and one for Path Part 2. And finally, we migrated existing file system calls to the Blender Studio adapters and replaced them with Abstract Path Resolver calls. By adding this abstraction layer between file system calls and the Blender Kitsu VSE core domain logic, we let the space for multiple studio and infrastructure to live, thus keeping Blender Kitsu compatible with both storage. Once Path Part 2 was integrated as an adapter, we were able to use the full potential of Blender Kitsu. We were able to switch shot version and export editing, etc. However, there were a few missing things to make it fully usable in our production. I will quickly go through them. Render preset management was added in order to ensure consistency between movies output among the projects. As the generated shots were used for validation, it was important to display their metadata, such as shot frame, steps, author, etc., as an overlay. The overlay system is using a customizable Blender scene and injects the VSE metadata within, basically. Then we had audio-only export, because our animation team basically rely on audio to do the lip sync, and audio is often updated among the production. We had to find a way to quickly update audio for every shot that was using it, basically. And finally, the most important point maybe, integrating edit into the pipeline was one of the motivations of this project. Also, for the integration to be complete, it was necessary to editing working file, basically. At the end of the month, we could finally say that the editing was a part of the pipeline thanks to the amazing Blender Studio tool, Blender Studio job. It is successfully used onto production. We generated a lot of episodes and shots. And that was one of our first try at non-context destructive pipeline integration. Now let's talk about another use case.
Thank you, Swann. So yeah, let's talk about the animation library now. So first thing first, what do we mean by animation library, and why do we need an animation library at Cube? So what is it used for? Our first concern is it saves a lot of time. It allows artists to reuse animation made by other artists, such as common work cycles and other stuff. It also helps us ensure consistency and artistic consistency throughout the project. If, for say, one character works in a very specific way, in the first episode, we want him to work in the same specific way in the last episode of the season, or even from one season to another. So this is also a big responsibility of the animation library. And the last thing is that it helps artists ensure the smooth transition between different shots. For instance, if we have, at the end of one shot, all the characters having a group pose, and we want the same pose at the beginning of the next shot, we rely a lot on the animation library to store this pose or animation to start the next shot with the exact same one. So those are the three main usage of our animation library. And what do we store actually in this animation library? We store all different kinds of data, but the first one are partial poses, so animation from only one part of a rig. It can be facial animation, hands posture, mouth shapes, eyebrow shapes, sometimes only one or two controllers. Of course, we also store full body poses. This is one of the main reasons the Pose library exists. And character group pose. In the case of multiple characters being stored at the same time, it creates as many assets as there are characters, and we can load them back to the characters in one click by selecting the different assets to get them back on the characters, because we also store in the assets the name of the characters. And animation as well, because we want to store cycles, such as run cycles, walk cycles, scroll cycles, or also other animation like jumping or anything else. So where do we come from in terms of animation library? Back in 2019, this was our second Blender conference, and we were very proud to present to you our brand new animation library tool, which was a general asset library that was used for animation. And this is the tool we've been using until this summer. So this is our old tool. It has a few advantages. First of all, it's cross-DCC compatible. So DCC stands for Digital Content Creation. So in the context of an animation studio, a DCC is just a 3D software. So our previous DCC was 3ds Max. We were switching from 3ds Max to Blender. And at the time, we had to rewrite most of our tools, pipeline tools. So we thought that by making them DCC agnostic, we would avoid the task to rewrite them the next time we would switch software. The fact is, we're not sure we're going to switch software now that we are using Blender. We've used this tool on six complete productions, so we know it very well. We know what it can't do. We know what it can do very well. It's quite robust. But it is the user interface is based on PySide, because we wanted to make it DCC agnostic. So we cannot integrate it properly into Blender user interface, and it has some limits about its feature and user experience. We were also missing some features, like blending between different poses, mirroring them, and we had compatibility issues when making our animation library evolve. It lost compatibility with the previous resources that were created for the latest project. And that was a big issue when moving to a new season of a said project. We struggled to get back the animation that was stored from the previous season. And that was a huge pain. And back in 2021, the Pose library appeared in the main branch of Blender. It was all nice, nicely integrated in the Blender user interface. We could drag and drop assets to the viewport. So we really had a serious look at it and starting thinking in the back of our mind that it would be cool to be able to use it in the context of our production. But it was still lacking features that we really needed at that time. And in the meantime, our own resource library was growing more and more complex because of new features that were added, because we had the support for constraints on different bones, and we were also storing bones into the resources to make sure that the constraints were working. So it made it harder to maintain and to debug, of course. The user experience was quite limited by the fact that it was an external graphic user interface. We could not do drag and drop into Blender because it was a by-side user interface. And we had really poor loading performances. So animators would rely on multiple libraries that serve different purposes on the production. And switching from one library to another is very long. So what they would do is, at the start of their day, they would open multiple instances of the tool and load all the libraries so that they would avoid switching from one to another. This is not the intended way of using the tool, but this is the workaround they found. This is why we started to look very seriously at using Blender Pose Library.
Once we decided to try the Blender asset systems, our leads benchmarked it and made few meetings to identify the technical logs. Basically, without an proper animation support and asset publishing to distant library, the asset systems wouldn't fit for the job. We also needed to tackle basic rate management issues and multi-asset import and export. As for Blender Kitsu, we were tight on deadline, but this time the production was already launched. Those constraints directly drove the pipeline integration, and let's see how. So before starting anything, the first question was, where do we work? At what level? To give a bit of context, in order to achieve our goal, we needed to interact with two Blender native components. On one hand, the Blender asset systems, providing built-in function to create and edit assets. On the other hand, the Pose library, which is a native add-on that is basically extending the asset systems with a useful set of tools for the Pose assets, such as blending and mirroring. It wasn't an option for us to handle the modification at the Blender core level, as it would require to test and publish a new Blender version in a running production. We also excluded the Pose library for the same reason, and because asset publishing and right management are a bit, maybe, out of the scope of the add-on. So where, basically? We end up creating a new add-on that basically patch and extend the Blender Pose library and change a bit how the asset systems is publishing assets. The Blender asset systems was already supporting asset action, which could contain either a single pose or an entire animation. So what do we mean by extending animation support? Well, the first major issue was the destructive asset loading behavior. Basically, the loaded asset action was replacing the existing one in the scene. We needed to add action patching, like the Pose Library. We had to apply action data in a less destructive way. Another concern was about asset previewing, more specifically animation asset previewing, because animation artist needs to know what an animation asset contains. Now let's see the good, the bad, and the ugly about our implementation. The good thing is action patching was implemented without issues. Creating and storing the previews wasn't a big deal. We used Blender GPU module to capture each animation frame quickly. Then, as we tried to stick with the existing Blender's data structure organization, we chose to store the animated preview within the action data block. However, displaying animated preview was trickier. The bad things were trade-off made for performances. On one hand, we had to rely on sprite sheet to reduce the preview loading time. So we basically render each frame and store them in a big sprite sheet, then read the sprite sheet from a GPU shader. On the other side, we had to display preview only from the side panels. Now comes the ugly part. Actually, to handle the animation preview refresh, we used an application timer dating the area at 25 frames per second, which is not a good thing. But in the end, animation was working. We were able to load action in a less destructive way on existing assets and to preview animation. As soon as the animation workflow was working, we started to add asset publishing. To give a bit of context, by default, a Blender asset library is composed of blend file, and on each of these blend files, you may have one or multiple data blocks marked as assets. Now, the thing is, asset creation happens locally, which means that if you have multiple assets per blend file, you could only have one person editing those assets at a time. But on the other side, you can load assets from any other blend of the library. In the context of a TV show production, we have a different approach. First, we rely on 2 animation libraries per project. The first one contains official and validated animation, and the second one is used for sharing various animation between animators, such as shot transition. With this collaborative approach in mind, we basically bent the asset library to our needs by adding the possibility to publish assets from external working file to distant library. And we ended up allowing only one asset to live per blend file to prevent concurrent publication issues. But with this approach, we came into limitations, such as the need to refresh the library each time an animator is publishing an asset, basically. Another big issue was the Blender catalog autosaving policy. Basically, Blender saved the asset catalog's modification on saving time. This behavior doesn't fit with a collaborative approach and led us to catalog corruption because multiple users were saving assets catalog at the same time, and asset catalog is one file. In order to prevent this, we added a basic right management system, which ensured that by default, a user can edit or remove only its own assets, but it can load any assets of the library. We also added 2 roles to control who can create assets and edit or remove any one of them. Given an existing library, the right definition happens in a single configuration file located next to the asset catalog file. If any definition file exists, the animation library will load it and limit action for users without rights at operator level. And that is basically preventing any user to do destructive modification of the Pose library. Few facts about the animation library. It was used on over 2 production. Our largest library have 1,600 of assets. It's quite light on the disk because we only store animation data blocks and not character rig and object in the asset file. And finally, we have at most 15 users creating assets for the same library, so potentially at the same time. Now let's take a step back and look at what we have done so far about these tools. One important thing to know is that it is still a work in progress. On the Blender Kitsu side of things, we didn't have yet the time to complete the adapters for other modules than the video sequencer, so the shot building, etc. We also need to ensure Blender 4 compatibility since we use Blender 3.6 LTS in our studio. And on the animation library side, it would be good to avoid application timer. We also need to rely less on context override because actually asset manipulation from BPY relies a lot on operators, which mean context-dependent operation, basically. In the future, we hope to have more low-level function for those. And again, Blender 4 compatibility, and it would be really interesting to see if some of the animation support feature could be upstreamed to the Pose library. However, we had 2 amazing tools adapted with minimal invasive methods in 2 months, and we ended up with an happy production management team and with happy animators. So what have we learned? For sometimes we tried really hard to create tools finally adjusted to our needs. So we ended up with a pipeline that was only suitable for our infrastructure and way of doing things. However, with the usage and the integration of Blender Kitsu and the extension of the Pose library, we saw that open source tools are a great way to ensure the reusability of a pipeline. In the future, we will aim at using and integrating more of those open source tools in our creation workflow so that we'll have more things to efficiently share with the community. So thank you for listening. Everything we talked about is available on our GitHub and on project.blender.org. Feel free to try it and to reach us about it. Thank you.
I guess we have a few minutes if there are any questions about what we talked about. I have microphones here. Yep.
It is on, yeah. So thanks for the great presentation, really enjoyed it. I was just wondering when you were talking about like trying to get the Blender Kitsu add-on and separating it from the rest. Have you guys tried the get subtree split command? Because I recently read the documentation about that and it seemed very promising, but...
Yeah, we didn't try that, but definitely looking to it.
But I think it's exactly aimed for this kind of use where you can
Okay.
keep pulling in only the changes for that particular directory in a way that you can still merge in your merge it into your own branch.
Oh, I
So
see.
it seems like the perfect fit, but I've never really tried it like that.
Can you give us the name of the command again?
I will later when I look it up. And yeah, I would love to talk more with you guys about like how you got animation support in there and how Blender can like be improved to support more like these use cases. So thank you.
Great, thanks.
Hi, thank you for the nice talk. I wondered, you just seen overlays I've seen 4 overlays in the VSE, and I wondered if that impact the speed of the rendering in any ways that you've seen in the VSE.
So actually, the overlay systems is basically using a single scene imported, and it's actually just one strip added on the top of the edits. The main performance impact is when we inject Kitsu strip metadata within the overlay editing field, the overlay field. So let's say we have a strip storing the shot name, etc., etc. The main performances issues were with those metadata injection, but it's still real time, so not a big issue.
Nice.
But I guess for metadata, if VSE would have some sort of built-in way of displaying metadata so that you wouldn't even need to do like a scene or whatever, that would help, right?
That would be awesome.
Okay, okay.
I think there's a way to burn in metadata, right? But I guess it was not able to display all the metadata we wanted. I think we met a limit. This is why we used this other way of doing things. Any other questions?
I have another one. You said you used the application timer. Did you encounter issue with using the application timer and with? I mean, do you have issue with models using also timers, or does it disable the autosave like the models do, or have you got issue with that? I mean, with using the application timers.
I don't remember any issue relating to this kind of behavior. The main issue we had were related with performances and with the way we draw the GPU widget on the top of existing UI on the side panel, but not about the auto-saving behavior.
Okay, that's really nice preview actually. Okay, then I have another one.
Oh, okay. Thank you, Sam.
On the rights policy you used for the Pose library, how do you know that which user is actually using the Blender at that moment for enabling the rights in the poll of the operators?
So as the source of truth for the user, we use the system username to know who is trying to access the assets. And for the source of truth for who worked on distant assets, we rely on the author metadata field of the assets.
Okay, nice.
Hello. I was wondering, is your team working in an office or from a distance, or?
All the team is working from the office, and if people are working remotely, they are actually streaming the screens of the in-house personal computer.
Okay.
So all the computers basically are in the office.
Okay. This way you have a pipeline only on local.
Yes.
Yeah.
Yeah.
Thanks.
So about pushing and updating like single data block assets to the Pose library, Christoph Lendenfeld is actually going to work on this in the coming months, among other things. So I'm not saying it's priority number one, but he is going to work on this. So I would like to invite you guys, or somebody from your company, to come and join the module meetings, because then you can actually like share your knowledge and have an impact on like the details of how this is going to work.
I think Swann is your guy.
Excellent.
That would be amazing. Yeah.
So it is, in principle, it's every Thursday from 6 to 7 Amsterdam time.
Okay.
6 to 7 in the evening.
Top.
Well, I guess that's it. Thank you, everyone. And see you later.